Lesson 7.3 Piecewise Functions continues. In this video, we will analyze scatter plots and determine regression equations for given intervals to write piecewise functions. What do you call a bear with no teeth? A gummy bear. Another joke from Iris. Alright, piecewise function. Oops. Includes different functions that represent different parts of the domain. So add this definition to the top of the page on the front side. Alright, analyze scatter plots, determine a regression equation over each interval to write a piecewise function that models the data. Round decimals to the nearest thousandth. Then graph the piecewise function on the scatter plot. Alright, so in this video I'm going to use Desmos to do this. In other videos I've shown you a graphing calculator. I've also shown you Desmos. Today we're going to use Desmos. First of all, on your paper, change the 0.05 to 0 because that's where this is actually going from. And then we're going to go ahead and move forward. So first thing we have to do is divide our graph into sections. And they gave us the sections. We're going from 0 to 3.5. So what I'm going to do is at 3.5, I'm just going to put a dashed line. Not that it's part of the graph, but it helps me to see my divisions. At 9, I'm going to put another dashed line. So each of these sections is a different function, and we have to look and figure out what each function is. So in that first section, we start up high, we end down low. So that's obviously an odd function, odd degree function. It looks like could be cubic, comes down to the second point, goes up, goes back down. It could be quadratic, but we're thinking, odd degree. So it could be like half a parabola maybe, since it is a piecewise function. So let's go ahead, take these points and put them into Desmos. So I already did that. Our first point was at 0.9. Second one is at 1.75. Third one is at 1.58 and 2.5 and so on and so forth. So I already put those in there because I didn't want to waste your time as I typed them in. So we said we decided it could be quadratic or it could be cubic. The r squared value on each is pretty close to being the same. So it's not a matter of which one. We can turn on the two functions and see what happens. If you look at the quadratic, it's actually touching more. It's about the same. So I would say we're going to go with the quadratic one on this and use the quadratic function. If you or I should say the answers on this will vary. You could choose either one and both of them would actually model what you're looking for. Well, in this case we're going to go ahead and choose the quadratic one. So we're going to go transfer that information onto our paper. So for the first line we have Okay, so we have negative 4.5 x squared plus minus 0.686x plus 9.06. It says round to the nearest thousandths. If you get a 0 on your third spot, you can drop it. That's why we have 0.45. All right, we're going to do the same thing with the next two parts. All right, so this part here, we start down low, we end up high. There's definitely some clear waveage in here, so probably cubic more than anything else. So we can come down to the cubic regression, take a look, see how it goes. Cubic function goes right through the middle of it. Its R squared value is 0.68. Quartic, it has a better R squared value, but Quartic doesn't model the information that we see here. Okay, this starts low, has some waves, it ends high, so we're going to go ahead and go with cubic on this one. Okay, so we're going to go ahead and transfer our information again. All right, so again, this information is coming from your regression equation. So it's the part that I highlighted over here. That's what you're using. So if you wrote down what I had before, change it to 0.93 x cubed minus 1.65 x squared plus 99.75 x minus 14.94. Difference between the two is when you're doing this, the points that we include are only the points that are in the intervals that are included. So 3.5, but in this regression we don't include anything that's on the line for 9. If they give you an open circle, those we include with the function that has the that doesn't have the line. That's not the ones that we don't include. We include open circles with them because they're telling us to use that point. If it doesn't have an open circle, we don't include it. All right, so let's get the last one real quick. So this last one here, it looks like a half a parabola, like it's curving up like half a parabola might, but then it sort of tails off to the right. So it could be a quadratic or it could be quartic. I would look and see at the two at this point and see which one's R squared value is a little better, and we will use that one. So the quadratic has an R squared value of 0.9651 and the quartic one is 1. So there's one that matches it perfectly and hits all the data points. So let's go ahead and use the quartic function for this one. So we're going to go ahead and transfer the last bit of information. All right, so we get negative 1.5 x to the fourth plus 63.253 x cubed minus 995.5 x squared plus 6,932.75 x plus 18,020. So what I'd like you to do is try number 11 on your own and see how you do. Okay, so let's take a look and see how I got what I got. So first of all, I decided the first part is linear, the second part's quadratic, and the last part's quartic. So let's look at Desmos and look at each of these pieces real quick. So for the first part, I mean, all I have is really 2 points. It could technically be any function you want, but a linear will model this just fine, and the linear one came out with a 1, which tells me we should use that. Okay, for the second part, it looks like it could be linear. It goes straight for a bit, but then it curves just a little bit at the end. So ideally, I would say quadratic is going to model that. It's like a half a parabola. So that's why I chose the quadratic one. I mean, looking at cubic, it has an r-squared value of 1. You could use that as well, but we'll go with quadratic. And then the last piece, there's a W in there, right? Right there, W tells me quartic. Okay, there's no question about it. The quartic model doesn't model it perfectly, like when we draw the graph. I forgot to draw the graphs for each of these, but you're supposed to draw the graphs. You can use this to figure it out. There's their quartic. It comes down, does some sort of little bit in the middle, and goes back up, but it models it well enough. Okay, it's the best model of it out there. So that's why we're using the quartic on the last piece. All right, with that, that's how we do piecewise functions given the information that is there.